one of the first things I'll start by saying is, if the word problem doesn't do it for you, you need to make sure you are identifying the variables you're using and what they mean. So on this first one, a group of friends agrees to equally share the cost of a $50,000 yacht. Before the purchase is made, one more person joins the group and enters the agreement. As a result, each person's share is reduced by $2,500. How many people were in the original group? So, without any instruction or methodology here, this might seem a little bit overwhelming. But there's kind of two scenarios. There's the starting scenario, and then some sort of change happens, and it affects our equation. So our group of friends, we don't know how many are in there, are going to share the cost of a $50,000 yacht. So a $50,000 yacht is going to be divided, the cost is divided between a certain number of people that we don't know. So I'm going to say N. And right there, N stands for the number of friends in the original group. And once that $50,000 is split evenly amongst those N people, what will you get? If I take $50,000 and divide it between 2 people, I get $25,000. If I take $50,000 and divide it between 5 people, I get $10,000. What is that number? $10,000 represents what? Right, each person's contribution, we'll say. So equals P. I'll say P stands for each person's original. And I'm putting original because both of these are going to change, right? The number of friends in the group increases, and therefore what's going to happen to the amount that each person has to pay is going to decrease. So that's the second equation. Now our 50,000 is going to be divided by what when one more person joins the group? What does your name start with? You know, my game gets ruined more times than it's successful. What does your name start with?
Oh, I already said both names.
I got you, Mitchell. Do you go by Mitchell or Mitch? All right. I had a Mitch last year, so I'm going to go with Mitch because it's easier. Mitch, how's that? N plus 1, exactly. So I'm going to divide that by an additional person, and as a result, the amount each person is paying is being reduced by 2,500. So P minus 2,500. So what do you call something like this in math? 2 equations, 2 unknown variables. A system solved by either substitution or elimination. This is a ringer for substitution because I already know that P equals this. So I can replace the P in the second equation with that. So I have 50,000 over N plus 1 equals 50,000 over N minus 2,500. So what type of equation is this, Morgan? Rational, yep. So we need a common denominator all the way across. The 2,500 might as well be put over a 1. Julia, what does this fraction need? N over N. And Marissa, what does this equation need? N plus 1. N plus 1. And the last equation needs both, an N and an N plus 1. Then we can drop our denominators. Sorry, I'm a little bit restricted on space. I'm going to move over here. 50,000 N equals 50,000 1000n plus 50,000. Such is life, right? Those annoying string of zeros. I'll show you a quick way to handle that in a minute. And then I have to distribute a negative 2500n to get negative 2500n squared minus 2500n. So one of the first things I'm going to do is just cross out the 50,000n on the left, cross out the 50,000n on the right. And then really, I'm just left with a quadratic, aren't I? What I am going to do is I'm sort of going to add all these terms over to the left so that my n squared is positive. So that's going to be a 2500n squared plus 2500n minus 50,000 equals 0. And I'm going to factor or use the quadratic formula. But I don't have a calculator. So let's use some strategies here to make our life easier. What can I do that will hugely simplify the issue here? Yep.
Can't you divide everything by 2,500?
Divide everything by 2,500, exactly. So I'll just have n squared plus n. And when I do the 50,000 divided by 2,500, just to be clear that we're getting this right, I'm going to cross off 2 zeros from each. And then how many times does 25 go into 500? Well, 25 goes into 100 4 times. And so I have 5 of these hundreds, so 4 times 5 is 20. So minus 20. So now it's factorable, n plus 5, n minus 4. And so n equals negative 5 or 4. Now remember what n stood for. When you have a context, sometimes numbers don't make sense. So even though they solve the quadratic, if it had no meaning, it would be fine, but it does have meaning. And n stands for the number of friends in the original group. No one's splitting the cost between negative 5 friends, correct? So we are going to reject that. And so what we find out is that there were 4 people in the original group. They could have also asked us what the original amount paid per person was going to be. In which case, if you know the n is 4, you could just split up that 50,000 into, it would have been 12,500 per person. They could ask you, now that the additional person is added into the group, how much is each person paying? So you could just think, okay, well now if there's 5 people, each person's only paying 10,000. Okie doke? So they could ask you any follow-up question. You'd still have to do all of that. We're good? We probably won't solve all of these. We'll just make sure we get through setting them all up. A wheelchair ramp with a length of 122 inches has a horizontal distance of 120. So I love diagrams. What is the ramp's vertical distance? So first part is to figure out this using Pythagorean theorem. So x squared plus 120 squared equals 122 squared. This one you would have a calculator for, or I would rewrite it so that the numbers weren't that big. So when I subtract 120 squared from both sides, (484) square root both sides, 22. So when it comes to access ramps for the disabled, every vertical rise of 1 inch requires a horizontal run of 12 inches. Does this ramp satisfy the requirement? For every 1 inch of rise, there has to be a horizontal run of 12. So, since we have 22, for every one of those 22 inches, we need a horizontal run of 12. So I'm just going to take 22 times 12. It's not ideal without a calculator, but I can do it. And it tells me that my horizontal run should be 264. Is mine good? No. I wonder if that's accurate. Oh, this is inches. I was thinking it was 120 feet. With a 22-inch rise. So no, this ramp's no good. It's too steep. Any questions? Okay. A rectangular garden measures 80 by 60. Draw it up. A large path of uniform width is to be added along both shorter sides. So here and here, we're going to have a border. And only along one of the longer sides. So I'll do the one on the bottom. So this is not actually extending up. The landscape designer doing the work wants to double the garden's area with the addition of this path. How wide should the path be? So we don't know how wide this path is going to be, so that's going to be our x. So x is the width of the path. And so right now, what's the area of just the garden? Nate? Okay, what's 8 times 6? 48, and then you got to add those zeros back. Not 480, 4,800, because you chopped off 2 zeros, so you got to add 2 zeros back. So right now the area is 4,800. We want the new area, once we add the path, to be double that. So we want the new area to be 9,600. And then the question is, what's the equation for the area of this whole shape? It's going to be the length times the width. How do we express the length? What do you think, Bailey?
Would it be 80 plus 120? Like,
Where's 120 coming from? This isn't 60.
oh, so I have it read like that.
Yeah, this is 60. The original garden is 80 by 60.
So it would just be like x squared plus 80? Or, I don't know.
Close.
X plus 80.
X plus 80 would just be this piece. Right? 80.
2x plus 80.
2x plus 80. Very good. This x plus the 80 plus another x. So 2x plus 80 is the length. And Connor, the width? 60 plus just 1x, or x plus 60. So what type of equation is this going to be, Olivia? Yeah, you're correct. It is. It doesn't fully look like one yet because we haven't foiled it out, but you would have to foil this out, get it equal to 0, and solve. Okay? So we're going to pass that. Number 4, after a 30% price reduction, You purchase a new computer for $840. What was the computer's price before the reduction? I'm actually curious, without any instruction, who can figure this out. Just given that percentages are something that when we're shopping we should be pretty fluent with. So I'm going to give you a couple minutes, and if you want to use a calculator, please feel free. If you were shopping in a store and that's kind of the scenario you knew, I want to know what you think the computer's original price was, so you really know how much money you're actually saving. Sarah, what do you think? How much do you think this computer was originally? 1,092. Raise your hand if you agree with her. 1, 2. Straight elbows. I can't see. You people are shy. You got 4 followers. Oh, is that 5, Trista? Yeah. 5 followers. Anybody think it's something else? Aiden? $1,200. Anybody agree with Aiden? You have 2 followers, Aiden. I'm sorry more people weren't following you because you were correct. The original price was $1,200. I think I know what the 1,092 people did wrong. Did you guys all take 30% of 840? Okay, and add that back on. If you were increasing $840 by 30%, that's what the price would be. But increasing $840 by 30% is not the same as whatever the original price was taking off 30%, right? Because you're supposed to take 30% of the original. So wherever your problem is starting, if you were trying to mark up 840 and 840 was the original price and you were trying to mark that up by 30%, then you would get to 1,092. But the reality is there was an original price already. We decreased it by 30%. So if we say X is the original price, whatever the original price was, X starts our situation. Then we are decreasing that by 30%, and you always take 30% of the original. So we're losing 30% of X, and we landed at 840. So on a problem like this, your first step to solve that equation would be to do the combining of like terms. 1 minus 0.30 is 0.70. And actually, this is kind of where my mind starts. I actually think in my head, okay, if I got a 30% reduction, then that means I'm only paying 70% of the original, right? If you get 30% off, you're actually paying 70% the price, right? So if I walk into a store and something costs $30 and it says 40% off, I actually don't calculate 40% of that and then do a subtraction. That's a two-step process, and I think a little bit longer. What I think is, okay, if I'm getting 40% off, that means I'm paying 60%. So I'll just figure out what's 60% of 30. What's 10% of 30? 3. So 60% is 6 times that. So 3 times 6 is 18. That would mean I'm paying $18 for that item. Does that make sense? Okay. So I might start this one very similarly. And this one I wouldn't be able to really do in my head. But if I know I'm paying 70% of the original and that's ending up being $8.40, $8.40 divided by 0.70 gives us $1,200. Okie doke. That's a lifelong skill right there, you guys. Percentages. Okay. Number 5. In 1954, my friend Roger Bannister of Britain, have you ever heard of him? Me neither. Cracked the 4-minute mile mark, coming in at 3 minutes 59.4 seconds. In the half century since, about 0.3 of a second per year has been shaved off his record. If this trend continues, by which year will someone run a 3-minute mile? So here's the first thing to realize is that Roger's world record was a combo of minutes and seconds, and when we're taking off 0.3 seconds per year, that's just in seconds. So to get all the units aligned, we should change this into seconds. So 3 times 60 seconds per minute puts us at 180, plus the 59.4 will be 239.4. We go with that? So 239.4 seconds kind of starts this scenario. And then we lose 0.3 of a second per year. Why not let that be y? Y is the number of years what? After 1954, since 1954. Very good. If this trend continues, by which year will someone run a 3-minute mile? And again, we're back to this being exclusively in minutes. 3 minutes needs to be changed to 180 seconds. And we would go from there. Okay? Now, y, when we solve it, is going to give us the number of years we had to wait. We're going to have to add that on to 1954 to actually answer their question. By which year? Okay, and try setting up number 6, not solving, setting up number 6 on your own, given that it's very similar to that yacht problem that we did a few minutes ago. So again, we're just setting up the equation that we will have to solve, not actually solving anything. Okay. This, I in the end, is what we would be solving. Things I would be looking for on your paper would be, did you define your variables? And did you kind of show the starting situation, and then wait, we're adding more people, so that situation, and then the substitution of, since this is what equals y, I can replace it down there, and that puts me over here. Are there any questions on that? Okay. I didn't put homework problems on the bottom of yours, did I? Well, we have to do homework, so I don't know why I did that. Okay, we're going to do page 105 to 107. Numbers 1 through 47. Threes and sevens. Okie doke. Should be about 20 problems.